Hello friends, so after completing market approach and income approach, third concept of doing valuation is a cost approach to valuation. As per IBBI syllabus, this chapter carries 7 marks for theory portion and up to 20 marks of numerical can come out of this chapter. So this is the syllabus as per IBBI exam. So this entire syllabus is very easy to understand and very scoring. 7 marks straightforward you can score, and numerical which come out of this session are very easy, which we will discuss in next session. So today we will cover theory part, and next chapter next session we will take up examples and case studies. So method of cost estimation for building, this is the first topic as per IBBI syllabus. So there are basically number of methods for doing cost estimation of the building. The first method is preliminary cost method. It is the preliminary estimate is being prepared to calculate cost of similar type of projects in a practical manner. In this estimate, approximate cost of each important item of work is displayed individually to know the necessity and utility of each item of work, including the cost of land, cost of roads, electrification, water supply, cost of each building. This method is also called abstract cost estimate, approximate cost estimate, or budget estimate. So the keywords here in this method is cost of similar type of projects. So here we do, as a valuer, we do estimation of a building by calculating cost of similar type of projects. And this method, this question, this 1 mark question can also come. This method is also called by other names, which is called abstract cost method, approximate cost estimate, and budget estimate. Next method of estimation is plinth area cost estimate. Plinth area is the area which is equal to length into breadth covered by external dimensions of a building at floor level. So plinth area rate of a building is calculated basis cost of another building with similar specification in the same locality. So here the keywords are cost of, here we try to calculate estimate value of a building basis cost of another building with similar specification in same locality. So open area, courtyards, etc. are not included in the plinth area. If building is multi-storied, the plinth area estimate is prepared separately for each floor. So these 2 points we have to note. So there are certain limitations of this method as well. This method of estimation has following 2 limitations. Number 1, ceiling height. So this method ignores height of floor of the building. So since this area is based on plinth area of the building, which is length into breadth. So if we are comparing 2 buildings of similar specifications, same locality, but having different heights, say one building is having height of 10 feet, roof height of 10 feet, and other building is having a roof height of 12 feet. So if we use this method, then our estimation will be equal. It will not take into consideration the height of the 2 buildings. And the second limitation of this method is large openings. If there are large openings in the building, then we have to make adjustments for them. So any building with large windows, and if our building is with small windows, then estimation may be incorrect. Third method of cost estimation is cubic rate cost estimate. So this method allows multiplication of plinth area of building with height of the building. So the limitations which we discussed in previous in second method of estimation has been removed in this method. So since this method takes care of height of the building, this method is better than plinth area cost estimate. So this question can come in exam. So cubic rate cost estimate is equal to plinth area of building into height of the building into per cubic cost of similar building in that area. So in second method we had used only plinth area of the building, height was not considered, but here we have also multiplied the plinth area with the height, so that gives us the cubic metric thing, and per cubic cost of same material can be considered for calculation of estimate of the building. So here height of building is taken from floor level to top of roof level. So please note these things. and this method is more suitable for multi-story buildings. Foundation, plinth and parapet above the roof level are not considered in this method. Next method of doing cost estimation is approximate quantity method cost estimate. This method calculates cost of superstructure and cost of foundation as under. So cost of superstructure is equal to total running length of the structure multiplied by rate per running meter of superstructure. And likewise we also calculate cost of foundation separately by multiplying total running length of foundation multiplied by rate per running meter of foundation. So for superstructure, running rate is decided basis quantities like brickwork for wall, woodwork, floor finishing, etc. However, for foundation, running rate is decided basis quantities such as excavation cost, brickwork, etc. Plinth, up to plinth level, etc. So because cost of construction involved in these two components, foundation and superstructure, involve different type of construction activity, and their cost may vary, normally vary. So that is why to achieve a better estimate of the property, so we bifurcate, as a valuer we bifurcate the structure of the entire building into two parts, foundation and superstructure, and we calculate their estimated value separately. So next method is detailed cost estimate. So this is the most accurate but lengthy method of estimations. Those who have been working with BOQ or tendering system, so there normally we use it. But however, in case of valuation, this method is normally not been used. However, this method is there. So using this method, estimated cost of the building is equal to sum total of bill of quantity of each item multiplied by rate of each item, plus contingencies up to maybe 3 to 5% of estimated cost can be considered. So bill of quantity of each item is like, first of all we will take out the blueprint of the building, and then we will calculate how much bricks, how many bricks are required to construct the building, how many cement bags are required, how much steel kg, what is the weightage of steel is required, reinforcement is required. So we calculate each and every part number, how much tile area is there. So we calculate each and every separate component building material item, and we try to estimate the quantity of each item based on the blueprint which is available with us, and then based on a certain cost. So that cost, maybe market cost, or maybe certain factors are there. Suitability cost is also there, depending on the purpose of the valuation that we will discuss in subsequent sessions. So based on that, we assign certain rate, what quality of construction is going to be done. So we multiply quantity of each item. For example, 1000 bags being required, and per bag is say 500 rupees cement bag, 300 rupees per cement bag. So 1000 into 300, so 3 lakh rupees of cement is required, right? So if we want say 50 kg of steel we want, and per kg steel rate is 50 rupees for example, then 2500 rupees of steel is required. So this is how we calculate value of quantity of each building material. Then we multiply it with the rate of each material, and then sum total of that amount gives us the estimated cost of the building. And on top of that, because it takes some time to construct the building, there could be inflation, there could be time overrun, there could be all cost overrun. So to take care of all those contingencies, 3 to 5% of the cost estimated is very well allowed to arrive at the estimated cost of the building. Next method is revised cost estimate. So revised cost estimate need to be prepared when original sanctioned estimate value exceed by 5%. So this is an important term. Question may come out of it. So when we do revise, in case original cost estimate increases because of cost overrun, if some cost overrun is there, say more than 5%, then we need to revise the estimate, and the revised estimate is called revised cost estimate. The increase may be due to cost overrun or time overrun. So key terms are, the increase may be due to cost overrun or time overrun, right? Cost overrun is like we had cost overrun happened because of inflation. So at the time of preparation of estimate, the cement bag was of 400 rupees, but because of certain factors, the cement, steel, sand, everything, all item prices have been increased, and accordingly total estimated cost has been increased. Second time overrun is like because of time. We had estimated that the building will be constructed within 1 year. However, it could not happen because of COVID or some other, because of flooding or waterlogging, some other reason, XYZ, any reason. So because of the time overrun, some extra cost are required to be incurred, which may also cause increase in overall project cost, estimated cost. Revision for revised estimation should be mentioned on last page. So if we're going to prepare a revised cost estimation, then revision of revised estimation should be mentioned on the last page. As a valuer, we should also always remember it should be mentioned last page. And then there is also a supplementary cost estimate. So these two terminologies appear to be same, but there is a difference between these two, and 1 mark question can come out of it, is to confuse the aspirants, IBBI aspirants. So in case of supplementary cost estimate, original scope of work increases. So the keyword is that in case of revised cost estimate, you have to look in the keywords on cost overrun, time overrun. However, in case of supplementary cost estimate, the original scope of work increases. So in case of revised cost of estimate, scope of work doesn't exceed. So scope of work, for example, we had estimated to construct G+1 structure with built-up area of say 2000 square feet. Subsequently, because of change in FAR or change in requirement or some other purpose, any reason, the owner of the property want to construct G+2 with FAR of 3000 square feet, right? So here scope of work has increased. So in case scope of work increases, then we have to revise the estimate, and that revised estimate is called supplementary cost estimate, not revised cost estimate. So there is a hairline difference between these two items. So next method of cost estimation is annual repair cost estimate. It is an estimate of annual cost to be incurred to keep the structure in safe condition. For example, whitewashing, painting, minor repair, etc. So it is the amount of expenditure that we are required to incur to maintain the building. It is a maintenance cost, or you can say annual repair cost of the building. So next topic as per IBBI syllabus is what are the different type of lives a building can have. So there could be 4 types of life. Number 1, economic life. It is the actual serviceable life of building, and is also called planned life or income yielding life. So keywords are actual serviceable life. Serviceable life, the period during which the property is supposed to generate some income, is having some income yielding capacity. So economic life of RCC building is normally considered to be 75 years. Well maintained building may have higher economic life than that of the negligently maintained building. The concept of economic life is normally being used in rental method. So this is also important statement for examination purpose. Then second type of life of a building is physical life. So let us see what is the difference between economic life and physical life. Physical life is the actual life of building before the building gets collapsed. So here keywords are building before building gets collapsed in case of physical life. However, in case of economic life, it is serviceable or income yielding life of the property. So this difference we have to understand for academic purpose. From 1 mark theory question may come out of it. And the second important question which can come out of this slide is that economic life is being used for income approach to valuation. However, physical life is normally being used cost approach to valuation. So poor workmanship, use of inferior building material, careless alteration, overloading of structure reduces the physical life of the building. Third type of life is legal life. Life of a building may also depend on certain legal constraints as well. So let us understand this concept with the help of an example. A building, if constructed on a leased land with unexpired lease period of 30 years, is having legal life of 30 years only. However, the building may have economic or physical life of 60 years. So if our expired period of the lease is 30 years, so for us legal life of the building is 30 years only. So life due to obsolescence. Obsolescence life is the life of building by which the building becomes obsolete due to changes in lifestyle in society. So we will deep dive into the concept of obsolescence and different type of obsolescence in subsequent slides. We will also try to compare obsolescence with depreciation in subsequent sessions. So this is the 4 type of life due to. So if there is a change in lifestyle of overall society, so the property is expected to be die. So the best example of this obsolescence or life due to obsolescence is chawls. The chawl is a concept which is very prevalent, which was very prevalent in Mumbai. So chawls with common toilet are the best example of this life. So normal economic life of a building, we should remember from practical aspect as well and from theory as well. So assuming normal occupancy and maintenance condition as expected, economic life of a building is as general. So monumental building normally have economic life of 100 years. RCC frame structure normally have economic life of 75 years. Then load bearing structure have 55 years, semi-permanent structure 30 years, and purely temporary structures 5 years. So next topic as per IBBI syllabus is what are the factors which affect life of a building. So first factor is moisture. So buildings which remain dry are less exposed to deterioration. Part of any structure, if remain underwater on permanent basis, is again exposed to less deterioration because of lack of oxygen. So this 1 mark question can come. The property is under is under water on permanent basis. So less deterioration, high deterioration. So this 1 mark question theory can come out of it. Thus parts of building which are exposed to wetting and drying are the worst hit on deterioration. So the part of building which are under drying and wetting, alternatively the building part is going into dryness and wetness. So that part is worst hit by the deterioration. So masonry, steel, RCC, timber parts of a building are the worst hit part of due to moisture. Next factor affecting the life of building is heat or cooling. Heat causes expansion and cooling causes contraction. So this 1 mark theory can come. 1 mark theory question can come out of this statement. Frequent heating and cooling of building causes thermal movement leading to weakening of material with low tensile strength. For example, masonry, waterproofing, etc. Next factor is settlement. Settlement of building normally affects masonry wall. Then chemicals, steel bar newly covered with concrete are protected against corrosion by passivation. So this is a keyword, passivation word, numerical theory question can come of steel surface due to high alkalinity of the concrete. I repeat, steel bars duly covered with concrete are protected against corrosion by passivation of steel surface due to high alkalinity of concrete. So what is passivation? Passivation is the process of removing free iron from the surface of metal using an acid solution to prevent rust. Other chemicals are atmospheric carbon dioxide. It reduces alkalinity of concrete leading to depassivation of steel reinforcement. So this is also 1 mark theory question can come. Then chlorides, they are normally being found near coastal areas and lead to reduction of alkalinity of the concrete. This lead to erosion of concrete and steel. And fourth type of chemical which normally affect the property are sulfate, and these are normally found in groundwater of some areas. So and these sulfates can attack concrete and cause weakening of foundations. Other factors are biological. Deterioration of timber is normally a biological process. In particular, termite attack can be very damaging. Plants grown on wall or roof may lead to cracks in masonry or concrete. So next factor is maintenance of building. So properly maintained buildings and timely structural repair of the building enhances life of the building. Use of building, excess use of building increases its wear and tear. Vibration, if some machinery with heavy vibration is being installed in the building, so it leads to, or the building is nearby to some railway traffic track, all these factors causes reduction in life of the building. Next factor is design and foundation criteria. Building foundations at shallow depth and in poor soil strata may cause settlement of structure and reduces life of building. So high-rise RCC building which are not designed with earthquake resistant feature like shear wall and special footing, etc., may have reduced life in earthquake prone area. So it depends on raft foundation, pile foundation, what type of foundation we are using, what is the design we are using for a structure of the building. It also affects life of the building. Now next topic is estimation of age of life. How to estimate age of a life. Age means existing life. So an experienced engineer can check age of a building based on the one or more of the following methods. So there are different methods through which a valuer can estimate approximate age of the building. So type of material used. So by looking at the property, so say mosaic floor is there in particular area. So after visiting the property, as a valuer I can understand that say approximately 30 to 40 years back this mosaic flooring was in trend. So in few locations why mosaic flooring in white cement was in trend. So tiles were in trend. So vitrified tiles were trend in trend, say almost 5 to 10 years back. So after checking the type of building material which has been used in the building, so as a valuer I can have a fair idea of the approximate age of the property. The next method of estimation of age, existing age of the building, is condition of different components of building and general condition of the building. So after looking at having overall view of the building, I can have a fair idea of the age of the building. Then by checking documents like approved plan, sale deed. So if I am able to get this approved plan, the building owner is having approved plan copy, so I can estimate that the plan was approved 40 years back, so approximate age of the building is say 38 or 39 years, because it would have taken 6 months or 1 year to construct the building. So by inquiring with owner and neighbors, so we can also ask to the owner, and we can also do a local inquiry by talking to the neighbors when this building was constructed, by using various health checkup equipments as well. So there are certain equipments as well with the help of which we can know near accuracy we can estimate exact age of a building. So first type of equipment is rebound hammer. It senses the soundness of concrete up to a marginal depth. Next equipment is impact echo tester. It finds out defect in the interior of concrete. Next equipment is ultrasonic tester. It scans through the concrete for the full depth and thickness. Then cover meter. It finds out the cover to the reinforcement. Reinforcement is steel bar inside the concrete. So as a civil engineer we all know. Profometer. It establishes configuration and quantum of interior reinforcement. Then next equipment is rebar. Photographer. It displays interior reinforcement, steel bar or skeleton. It gives a picture of interior skeleton of the reinforcement inside the concrete. Endoscopic device. It is used to examine voids in the concrete. That further tells about the quality of construction, quality of concrete. Thermographic device. It is used to locate possible defects in a new building. Crack measurement device. It measures surface cracks. Permeability tester. It tests for water penetration in concrete. Thickness gauge. It measures the thickness from the surface. Leak seeker. It locates source of leakages, if any, in the building, in the structure or column beam or a wall. So corrosion analyzer. It measures extent of corrosion in reinforcement. Corrosion is equivalent to like cancer in concrete. So this 1 mark question can come. And then next equipment is X-ray. It scans inside the concrete. So any type of examiner may give you name of any equipment and may ask about what this equipment is being used, for which purpose it is being used, can be asked in exam. Next equipment is carbonation test. It measures carbonation depth of concrete measured by using a solution of phenolphthalein. So this 1 mark theory question can come out of it. Then carbonation test, which chemical is being used? So phenolphthalein. Spraying on concrete. In case concrete is with alkaline nature with pH value of 9. Again, you please remember this 9 pH, and the solution turn pink color. You please remember, it may come in examination. The next type of equipment is ground penetration radar, GPR. In short form of this equipment is GPR. This is a geophysical method that uses microwave or radar wave to detect subsurface object. Now, what is total life of the building? So in previous slide we had discussed about existing age of the building. Now we are talking about total life, existing plus future life. So total life of the building is age of the building, what is the present age, plus remaining economic life of building. So please understand here, remaining economic life of building is equal to lower of remaining physical life or remaining economic life. So it is a very important concept, and we should understand. Examiner may ask you, may give you physical life, economic life, age of the building, and may ask a question about what is the total life of the building. It's a very simple and tricky question which can come in examination. So next topic is obsolescence. So there are different type of obsolescence. So for going deep into the type of obsolescence and the understanding with the help of example, let us understand what is obsolescence. This is a very important topic. At least 1 mark question is sure shot out of it. So obsolescence is a state where a building is no longer wanted even though it may be in a good condition. I repeat, obsolescence is a state where a building is no longer wanted even though it may be in good condition. There are basically 4 types of obsolescences which affect real estate. Functional obsolescence, economic obsolescence, technological obsolescence, physical obsolescence. So we have to understand what are these type of 4 obsolescence. Examiner may give you one type of obsolescence and may ask. It is a technical obsolescence, may give you 4 options, whether it is functional, economic, technical, physical. So we have to understand these, which type of obsolescence falls under which category, and we can easily score at least 1 or 2 marks question is must out of this topic. So what is functional obsolescence? Sometimes a building, because of its old planning and outdated design, doesn't meet present day requirements. So keywords are the building is no more able to meet present day requirement. For example, a chawl with common toilets block. An old palace may be in good condition, but no one like to stay in it. However, if these palaces are converted into hotel, they may find good demand. A multi-story office building that doesn't have an elevator. So these, because the building is not having any elevator, so it has no functional utility. So it has functional obsolescence because of non-availability of that elevator. The overall value of the property will go down because of functional obsolescence. Next type of obsolescence is economic obsolescence. It is the decline in property value due to external factors. So keywords are decline in property value due to external factors like zoning changes, recession, adverse traffic changes, construction of public nuisance type properties like jail, sewer treatment plant near to the property. For example, residential building existing on a plot which is situated in commercial zone area. So this habu is not made. So if we have a plot with commercial zoning, a piece of land on which commercial construction is allowed, I can construct a shop, I can construct a mall. However, instead of constructing the commercial building, I prefer to construct a residential. So I am underutilizing that property. So that is kind of economic obsolescence. Dilapidation, or also called decay or deterioration of building, leading to huge repair cost. So if rental value of property in a particular area falls severely, either due to bad neighborhood or due to migration of population to a newly developed town centers having better amenity. So this is another type of economic obsolescence. Then third type of obsolescence is technological obsolescence. It is decline in property value due to latest product, technology, workmanship, etc. So if some technology, new technology has come, so it may lead to properties with old technology or old furniture fixture or old sanitary wares may get lower value. So example, load bearing building, timber structure are technologically obsoleted and people prefer to have RCC building because of thin walls. So in case of load bearing walls, we used to have walls of 9 inch or 13.5 inch or 18 inch. However, in case of RCC structure, frame type structure, we have walls of only 4.5, thin walls, because it gives us more carpet area. So people don't prefer load bearing buildings these days, and they prefer RCC structure, and it may lead to reduction in overall costing of the buildings or structure with load bearing. So wooden windows are being replaced with aluminum window. Then the best example is Indian sisters have been replaced with Western sisters. So anyway, if we have 2 buildings and one building is having Indian system, Indian toilets, and the nearby property is having Western toilets, right? So building with Western toilet will have more value, or property with Indian toilets will have little bit less value because of the technological obsolescence. So next type of fourth obsolescence is physical obsolescence. This is the normal wear and tear of the building, and it gets escalated due to poor and deferred maintenance of the building. Degree of physical obsolescence depends on factors like manner of usage, environmental aspects, natural force aspect, and accidental aspects. So keywords here in this physical obsolescence, it is normal wear and tear, and it depends, it can be reduced with better maintenance of the building. Next concept is depreciation. So depreciation, it is the decrease or loss in value of property due to structural deterioration, use, wear and tear, decay, and obsolescence. So there are various methods of calculating depreciation. So before we'll compare obsolescence and depreciation, let us first understand what are the different methods of calculating depreciation, because numerical or case study up to 12 marks may come out of it. And if we understand these 4-5 methods and we know their formulas, and we will not understand only formulas, but we will also try to understand the derivation also. So if you will not be able to recall those formula, you can derive those formula then and there itself. So let us start with the methods. So first method is a straightforward straight line method. Here quantum of depreciation, it is in absolute terms in each year remains same. So absolute depreciation amount is equal to depreciation is equal to, so C is original cost of the property or replacement cost of the property, C, and then S is scrap value or salvage value. So there is a difference between scrap value and salvage value from theory perspective. So and the same has been discussed in chapter 8 part 1 session 1. What is the hairline difference between scrap value and salvage value, but for numerical purpose don't differentiate between these two. So these two terminologies can be used alternatively, and you have to, normally salvage value word will come, but even if it comes as a scrap value, so we are not supposed to differentiate between these two from numerical perspective. So S is scrap value or salvage value, and N is economic or effective life of the building, total life of the building, it is not age, and D is annual depreciation. So we'll try to understand all these concepts with the help of example in next session. Second method of calculating depreciation is constant percentage method. It is also called linear method, or it is also called WDV method or declining balance method. So please remember all these four names. Numerical is more likely to come out of it, even if 1 mark or 2 mark question is must out of this formula. Examiner may give you name of constant percentage method, percentage constant method, or linear method. So we should know that it is nothing but WDV. So in this method, depreciation percentage remain constant. So in previous method, the absolute terms depreciation was constant. However, in this method, percentage depreciation remain constant. So value of property after M year is equal to is CM after M year, if M is the percentage of the building, and is equal to C into SV divided by C raised to power M divided by N, where C is replacement cost RCN, and SV is salvage or scrap value of the property, M is present age of the building, and N is total effective economic life of the building. Let us try to understand how we have derived this formula. So if you forget this formula, you can derive it with the logic in the exam itself. So this is the derivation of the formula. If total life of the building is N years and salvage value of building is S, so using compound interest formula we know. So salvage value is equal to S is equal to C, which is the initial value, capital value or RCN, multiply with 1 minus D, which is annual depreciation, raised to power N. So using this formula we can calculate annual depreciation is equal to, percentage depreciation is equal to 1 plus S divided by C raised to 1 by N. So this is the annual depreciation. So now if we want to calculate present value of the depreciated value of the building after say M years, right? So what is the value? So CM is equal to C original RCN multiply by 1 minus D raised to power M. So here we had considered N was total life, and here present age of the building. So CM is equal to C into, if we open these, we'll put value of D from this formula to this, so it will be equal to this. So please remember this formula is very important, and there is a derivation of the WDV formula. Next method of calculation depreciation is sinking fund method. This method of depreciation is widely used for estimating net present value of the building, or market value of the building, present value of the building, or depreciated replacement cost of the building. This method is considered to be more appropriate and scientific method for calculating depreciation of the permanent type of buildings which have pretty long lifespan, because it gives lower depreciation per year in initial years of lifespan of the building and higher depreciation per year in later years. So if a building is having so long span of say 80 years or 60 years, so during initial year the percentage depreciation will be less, say 0.1%, 0.2%, 0.3%, and in later years maybe 50th or 60th year the percentage depreciation will be very high, maybe 3%, 4%, 5%, right? So lower depreciation in initial years is more in concurrence with the actual physical deterioration pattern of most of the buildings. So majority of building need lower maintenance during the initial year, and wear tear of a building during the initial year is normally very less as compared to later years. So this formula is having more in concurrence with the deterioration pattern of the building. So this method also takes into account interest income on sinking fund. So if we have a building and we need to we are parking certain amount for maintenance of the building. So we will earn certain interest. So this sinking fund concept we have already discussed in the previous I think income approach to valuation. So you may refer for details. So these are the steps involved to calculate depreciated replacement cost or NPV of the property, net present value. So first step is we have to calculate ASF or SFF. So this is the same formula which we have discussed in previous sessions. So for derivation, you please refer to those slides. I think income approach we have discussed fourth session. So this formula we can derive, derivation is given. So first of all, we have to calculate sinking fund factor, which is being used calculated through this formula, and here IS is interest on sinking fund and N is total life of the building. Then we have to calculate accrued sum of depositing ₹1 for M year, where M is age of the building, so APA. So APA formula also we have calculated in previous sessions, income approach session number 4 I think. You can refer, and the link is given in description box below. So after calculating ASF and APA, we have to calculate percentage depreciation till M years age. So multiply SF and APA into 100. So it will give us the percentage depreciation till mth year. So if total life of the building is 60 years, present age is 10 years. So this figure ASF will be calculated for 60 years. This we will calculate for 10 years, and then total depreciation till 10th year will be equal to this factor multiplied by this factor into 100. It will give us the percentage depreciation till mth year, 10th year. So then calculate depreciation amount that we know. Replacement cost is given to the given in the question. So percentage depreciation calculated from here, multiply by replacement cost. That will give us the depreciation amount in rupees or absolute terms, and then market value of the property or depreciated replacement cost of the value of the property or present value of the property will be equal to replacement cost minus depreciation amount. That will give us the value of property. So fourth type of calculation of depreciation is quantity survey method. Normally numerical doesn't come out of it, so from academic purpose you should know name of the method and little bit about the method. So an experienced valuer estimates certain amount of depreciation for each year based on some logic. That is all about this method. Numerical doesn't come out of it. Next question, fifth type of calculation depreciation is sum of digit method. 1 mark question can come out of it. 1 or even 2 marks question can also come. So this method gives lower rate of depreciation in earlier years and more rate of depreciation in later years. So 1 mark theory can come out of this statement. Then if total life of the building in N is N years and present age of building is M year, right? So N is say 60 and M is say 10 years. So percentage depreciation in mth year, say we are talking about 10th year. So what will be the depreciation in 10th year is equal to M divided by N, sum total of N, right? So AP sum series of N. So if we remember formula for sum of AP series, so N is equal to N plus 1 divided by 2 multiplied by N. So this is simple arithmetic progression sum series which we had read, I think in class 7 or 8. This is same formula. So this gives us the depreciation, percentage depreciation in a particular year, right? And if we want cumulative of it, then it is equal to summation of M divided by summation of N is equal to, if we open denominator and numerator, so it is equal to dm is equal to M plus 1 multiplied by M divided by N plus 1 divided by N. So it is again sum total of AP series. So what is the difference between depreciation and depreciated cost? So these two terminologies are very confusing. Very simple concept is there. However, these terminologies are very confusing. Normally we solve entire numerical, we get all the values, and we may mark wrong answer in the question. So always whenever any depreciation word is there, so please try to read that question twice or thrice and try to understand whether the examiner is asking for depreciation or depreciated cost. So these are two different things. So depreciated cost is equal to replacement value of the building minus depreciation cost. So this is a formula. So depreciation cost is how much depreciation has been done, right? And depreciated cost is what is the value of the property after deducting depreciation from the replacement cost. So next very important topic of this thing is depreciation versus obsolescence. So what is the difference between these two? 1 mark theory question can come out of this table. So first is reason. So in case of depreciation, this is a physical loss in the value of property due to its use, wear, tear and decay. So depreciation occur because of physical loss in the value of property, and obsolescence, this is the loss in value of property due to change in design, fashion, in structure of other properties, other nearby properties, change in utility, demand, and also specific detrimental influences. So other than physical factors, because of taste, lifestyle, or some other factors, obsolescence can happen. Then quantum depend on age of the property. So more the age, higher will be the depreciation. So this is a simple formula. But obsolescence depend on normal progress in arts, inadequacy to present or growing needs. So there is no as such, there is no definition that old age properties will have higher obsolescence. So it depends on the taste, change in taste, generation gap, art, lifestyle, that depends on the age of building. It is directly proportionate to age of the building. So higher the age of the building, higher will the depreciation. It has no relation with age of the building. So lower age buildings may have higher obsolescence or vice versa. Calculation method. So we already discussed various methods to calculate depreciation. However, for obsolescence there is no specific method for calculation till date. So that's all for cost approach to valuation. And if you go through these PPTs and stuff, you will be able to score 100% out of 7 marks of theory. And next slide, before I'll tell you what we are going to have in our next session, I would request you to please subscribe to this channel and click on bell icon so that you will be immediately notified about the next video which I'm going to upload soon. So examples and case studies. So next session we are going to discuss about the examples and case study on cost approach to valuation. So whatever methods of calculating depreciation have been discussed in this session, and we will also understand analyze different examples and case studies wherein properties having multiple age of the buildings. So upper floor is having 10 years old, lower floor is say 20 years old. How to calculate depreciation under different circumstances and different methodologies. So what type of questions and numerical and case study can come. So by doing these 2 sessions, you can easily score a minimum 10 marks and maximum say 20 marks or in IBBI exam. Thank you.